So while switching the slides, I just mentioned that, so Fred and Norm, they work with dozens of startups a year. You basically heard from the experts who do it well, what goes on there. Um, and my experience was with one startup, with spin out from Stanford, so I don't want to project that one data point. Extrapolating from one data point is dangerous. But what I do want to point out is that they talked about this funnel. They have the big funnel that goes in, and then where their funnel ends, it goes in a VC funnel. The general premise of what I'm going to talk about in iCore is a big chunk of it, is how to improve what you put in the funnel. If you can put better stuff into the funnel, that makes their jobs easier. It increases the likelihood of everything downstream. And also, even if you educate faculty on how to commercialize and give them the sort of entrepreneurial mindset and skills, it may not be this particular invention disclosure, it might be their next one, and they've learned those skills already. So that's the premise of what I'm going to talk about. All right, so I forgive my silly sense of humor. I was just trying to fit I in there somewhere, and I came up with Eric. But you know, why shouldn't ERCs become Erics? And iCore, I see Grace Wang in the background. She's our NSF iCore, one of our big champions over at NSF. But what is iCore? Just how many people have heard of iCore? Probably most of you. All right. How many people from a node or a site school? All right, smaller number. I'll keep this really quick. But you know, basically, NSF is trying to do more with the $7 billion of research they fund every year. How can we have more economic impact? If any of you get an MIT Technology Review, you might have seen this a couple of years ago. I know our dean, Daryl Pines over there, knows who this is. This is Buzz Aldrin, right? Not the first man on the moon, the second man on the moon. Not everybody has to be a founder. It's still good to be the second or whatever. But what I want to highlight is what he said here. You promised me Mars colonies, instead I got Facebook. You know, our planet has big challenges. Clean water, energy, food supplies. And so, you know, part of the motivation at iCore is let's have more big innovations coming out of what we fund that are going to help our future survival. And so this program was developed by entrepreneurs, taught by entrepreneurs. There are 7 leading universities around the country that have partnered up with partner schools. So these are all node schools. All 3 of our schools, not coincidentally, a part of that. Texas A&M was up here earlier. But we've got representatives around the country, and we're spreading this training and this mindset. And the goal is to improve the odds. These are just some quotes from some faculty who had gone through iCore, basically saying it's been sort of a life-changing, new perspective kind of thing. And a lot of them characterize it as it's been kind of fun because it's really practicing the scientific method, which they've done for years, if not decades, but not in their labs, but instead in the marketplace, in industry. And the experiments they're conducting are a different kind of experiment, but it's the same sort of process, and it's been very enjoyable from that standpoint. And pretty much universally, everybody feels all faculty really should be have some level of familiarity with this process. President Obama, the last White House demo day this summer, announced expansion elsewhere. So why don't we require ERCs to be ERICs? So why not? Well, first of all, what do you do in iCore? You jump in, you do 100 interviews. That sounds, what? 100 interviews? You talk to potential customers. Why? Many of you have heard different versions of this famous saying from military generals, no battle plan survives first contact with the enemy. You can be a brilliant military strategist, anticipate all kinds of things, but you just don't know until that first shot is fired how things are going to go down. And you can't rely on, I have 99 different options, and we're going to stick just to those based on what happens. No, and so Steve Blank, who many of you may have heard of, he's one of the founders of Lean Startup. He has this corollary to that, not for the military, but in business, which is no business plan survives first contact with customers. And the same thing applies. You can be a brilliant business strategist, but you just don't know until you launch your product into the marketplace what's going to happen. So the number one reason that startups fail is building something nobody wants. If you Google it, this is what comes up. And the key thing I want to highlight is that seems sort of crazy. Like, what? How can that? Not what? 90% of startups fail. How can so many of them build something nobody wants? Well, the key thing is it's not that you were completely wrong. You may have been 50% right in understanding the problem out there and solving that problem, but you didn't realize that what the customer cared about is the thing you solved plus this other chunk. And unless you deliver the 100% solution, not the 50% solution, unless you deliver the 100% solution, they're not going to buy. We experienced this firsthand at our startup. We were within 2 months of going bankrupt because we built the wrong thing. It was probably even 75% right. But put yourself in the shoes of the customer. They're looking for an improvement on speed to market, in cost savings, in whatever benefit they need. And if you only deliver 90% of the solution, they still have to go out and find the other 10% before they receive those benefits that you're promising. So you have to deliver the 100% solution, and that's where most startups fall down. And so if you don't trust Steve Blank or military tacticians, maybe you trust Richard Feynman. This is a famous saying, it's easy to fool yourself. And this applies equally well to the startup world. So Steve Blank said, hey, unlike those military battles where if you went up to the enemy beforehand and say, hey, what are you going to do in that first hour? Where are you going to attack? Of course, they're not going to tell you. But in the business world, industry will happily tell you what they need. They will happily tell you what's keeping them up at night, preventing that manager from getting a promotion, preventing that company from hitting their annual sales goals, preventing them from delivering their next product. They will happily tell you that if you have a prospect of delivering a solution. So go out there and talk to them and ask them. But the key is you can't go out there and sell. You have to go out there and ask. You want to learn from them. If you go out and pitch what you're doing, they're skeptical. Well, there's a reason nobody's come up with a solution. Why do you think you've come up with a solution? But if you approach it from, what have you tried, what hasn't worked, so that can better inform our research, so we might be able to come up with a solution to what you're struggling with.
Dean, actually, go back to that acronym there, get out of the building, to us is 97% of the value we get out of the Lean Launchpad process. It turns out it's much easier to stay in your lab and talk about why your invention is great and have your graduate students agree with you than it is to go ask people and find out, and when they don't care about whether you like them or not. So it's very easy to do SBIR 1, SBIR 2, 7 years of research, more grant applications, and just put off that scary customer interface. But these guys won't let you do that, which is great.
Yeah. Thanks. So I wanted, if you'll indulge me, I want to share a quick story. I know some of you, I know Richard knows this story because they've embraced design thinking, but just show of hands, how many people know the Doug Dietz GE Healthcare MRI scanner? Okay, so apologize for the repeat, but it's worth sharing because I think it really kind of ties a lot of what we've heard today together. So Doug Dietz was an engineer, an awesome engineer, an award-winning engineer at GE. They designed this MRI, and Doug said, hey, I want to go out to a medical center and see this baby that we just put together, see how it works. It's awesome. We spent years on it. It's fantastic. So he goes to an MRI center. He's talking to the technician, and the technician said, it's great, it works great, and he's feeling good about himself. And then the technician says, well, actually, there's a patient coming in soon, so you're going to have to leave. And he's like, okay. So he walks out, and in the hall, he sees this little girl being dragged towards the MRI room, crying. And he hears a parent saying, you're going to have to be brave. It's going to be okay. And his heart sank. He's like, those awards for this MRI mean nothing. I mean, this kid is terrified of going into this machine that looks like it's going to smash your head. There are typically like these yellow crime scene stickers leading on the walls, leading up to the door about warning, right? So, and he realized this is the worst experience in the world for a child. And so he had coincidentally gone to Stanford, the D School for the Executive Education Boot Camp, and learned about design thinking, and he brought it back, and he met with children, parents, technicians, people, receptionists, everybody, and they all worked together following the design thinking process, and they redesigned the MRI experience. The technology didn't change one bit. The technology worked every bit as well as it did out of their lab. But you can see the dramatic difference between the head chomper and now this canoe where there were actually these stones leading up even from like the parking lot through the reception area where you had to kind of follow the yellow brick road path. And they had the whole story where if you lay still in the canoe, then you won't scare off the fish, so you'll start to see fish jumping over you. And there was another one which is a spaceship, and if you've ever had an MRI, it's got this scary, awful pounding sound, which scared a lot of kids, so they turned it into the story and said, well, it's about to go into hyperdrive. Can you listen for when you're about to go into hyperdrive? Completely changed the experience. They had aromatherapy. They had, so it smelled like a jungle. All kinds of really, really cool stuff. And the end result was, no kidding, that he heard kids actually say to their parents, "Can we come back tomorrow?" All right? And so this was a huge win. And so the key point here is this is actually where design thinking might meet lean startup a little bit. So the design thinking really gave Doug a new sense of empathy for an audience he hadn't really thought about. But this was a hard sell to the managers at GE. First of all, there are some slight changes to the MRI cosmetically, not a lot, but it's hard to even justify the cost for that. And plus, moreover, most of the changes are to the room. You can kind of see from the pictures for the actual room itself, the facility, the welcome area. And to do it right, they estimated that these renovations cost maybe about $40,000. So he had a tough business case selling why they should do this, because going up and saying, "Do you see how many kids are crying versus not crying?" is not a very compelling argument for the people way up here. And so this is where Lean Startup came into play. What's the business model? What's the value proposition to who? And here's where he learned something really interesting and sad and scary. 80% of kids going in for MRIs ultimately have to be sedated by an anesthesiologist because they're so distraught. And that often means canceling that appointment and rescheduling for another day and coming back. And being under means that you're in the facility for 4 hours. There's all the prep going there, then you go under, then there's recovery time, versus 90 minutes if you don't have to go under. So there, the dollar value proposition came into play. They could increase the throughput through their MRI and get more screenings every day by adopting this sort of adventure series. And the payback period for the MRI and the room and everything shortened dramatically. They went from a backlog of, you wanted an MRI appointment, you had to wait 2 weeks, to having availability the next day. That's what the higher-ups cared about. Yeah, of course they didn't want the kids to cry, but it wasn't worth the $30,000 investment or the changes to the MRI on the GE side. So, where I want to kind of end this is, it poses some interesting questions. Should we and can we foster more empathetic and impactful engineers? Where does an engineer's job end? Is it right at the end of the technology? Is it at that design thinking phase of the experience? Does it delve into the business model side of things where you get the buy-in? I personally think it should be all the above, especially for those who are interested, but what's the minimum level that everybody should dip their toes in? So are there models for adopting this, and you've already heard about some of the schools that are incorporating design thinking and lean startup. University of Maryland's no different. One of the things that we've tried to do is, I-Corps initially came in under Dale Pines' leadership in engineering, but now it's become a campus-wide initiative with the Office of the President, the Provost, my office, the Tech Transfer Office, the Business School, all teaching this. And we've had teams not just from engineering, but from agriculture, social sciences, public health, which has been great. But that only goes so far. It's been a nice article on Steve Blank's website about what's going on at Maryland. But how do we take this further? So I'm going to leave it with some prompts for the breakout session. Because when Doug Dietz went back and redesigned that experience, he brought in many, many more people than just engineers, which is who he worked with initially, social scientists, public health people, and so on. So my questions, actually I'll do the second one first. Often we hear multidisciplinary research centers, and by multidisciplinary, people really mean, oh, you've got chemical engineers and civil engineers together? That's radical. But what about social scientists, business, and such? So where should those disciplines be brought into research centers? Should it be at the earliest research activity phase? Should it be a little bit later in that customer discovery, empathy, innovation phase? Should it actually be in the commercialization phase? So that's one prompt. Second one is goes back to that question of where does an engineer's job end, or does it not end? So for engineers involved in these research centers, and just using the MRI example, are they done when they design the technology? Should they spend time with pediatric patients and learn about these pediatric sedation 80% rates? Is that sufficient? Should they go further and learn about the throughput and payback times for MRI machines on the business model side? Or should they even go so far as to be part of the commercialization activity, whether it's in a startup or joining in partnership with industry? So those are the two prompts. And I'll wrap it up there.
Well, I thank you, the three of you are very good, and you all are clearly